Let's move ahead with solving more important questions that will help you strengthen your concepts and improve your exam performance. Now, the next continued question is, read the sentence and choose the word with the correct spelling from the options given. The hotel can dash up to 500 guests. The hotel can accommodate up to 500 guests. It is very simple question. Given four options, just we need to find out the proper word without spelling mistake. So that hotel can dash up to 500 guests. Hotel can accommodate up to 500 guests. So here only one C it is there, only one M it is there, and only one C and one M. The proper spelling for the accommodate is ACCOMMODATE. So the correct option for this one is the fourth one. Next question is, which of the following is correct? M raised to 4 minus 256 equals to M square plus 16, M square minus 16. And one more B, M raised to 4 minus 256 equals to M plus 4I into M minus 4I into M plus 4 into M minus 4. It is a type of factorization. Factorization in maths is the process of breaking down a number or algebraic expression into a product of simpler numbers or expressions called factors. So here we have some of the important formulas related to factorization in maths. A square minus b square equals to a plus b into a minus b. A plus b whole square equals to a square plus 2ab plus b square. A minus b whole square equals to a square minus 2ab plus b square. Thus a square plus b square equals to a plus b whole square minus 2ab. A cube plus or minus b cube equals to a plus or minus b into a square plus or minus ab plus b square. So now here this equation, it is very much suitable to the first given equation here. That m raised to 4 minus 256 can be written as m square plus 16 whole square. M square whole square minus 16 square. That is m square is nothing but a, 16 is nothing but a b. So here we have a minus b into a plus b. M square plus 16 into m square minus 16. So the first equation, it is correct according to this one. The first equation is m raised to 4 minus 256 can be written as m square whole square minus 16 square. This is equals to m square minus 16 into m square plus 16. Now in equation 2, m raised to 4 minus 256. M raised to 4 minus 256 can be written as m square minus 16 into m square plus 16. So m square minus 16 can be written as m minus 4 into m plus 4 because it is m square minus 4 square. And m square plus 16 can be written as m minus 4i m plus 4i. So here we have a 4i is nothing but a 16i square. So 16i square value it is a minus 1. By substituting that I square equals to minus 1, it will becomes m square plus 16 here. So now when we have a m square minus 16 into m square plus 16, already we are proved here. What is that? That is nothing but m raised to 4 minus 256. So m raised to 4 minus 256 can be written in this way. So both A and B are the correct options for this. The next question is, which of the following is not a quadratic equation? First of all, before diving into this solution, what do you mean by the quadratic equation? A quadratic equation is a second degree polynomial equation, meaning the highest power of the variable is 2. Its standard form is y equals to ax square plus bx plus c, where a, b, c are the constants and a is not equals to 0. Like that only. Now when we have a power is 2, it is of the quadratic equation. If the power of the variable is 1, then it is called as a linear equation. A linear equation is an algebraic equation of the first degree, meaning the highest power of the variable is 1. It can be written in the standard form y equals to mx plus b, where m is the slope rate of change, and B is a y-intercept, where the line crosses the y-axis. So here we have a, now we have to check the first equation, x minus 2 whole square plus 1. That x minus 2 whole square is nothing but once again a minus b whole square. That is a minus b whole square can be written as a square plus b square minus 2ab. So here we have a minus x square minus x square minus 6x plus 2 equals to 0. Now it is a quadratic because the highest power of the variable is 2 here. Then next one is x into 2x plus 3 equals to x square plus 1. So here we have to simplify this one to x square plus 3x, and here we have a x square. To x square minus x square plus 3x minus 1 equals to 0. Then again the highest power value, it is x2 here. So it is also the quadratic. And next one is x plus 2 whole cube equals to x raised to 3 minus 4. So by simplifying this one, we'll get x square plus 2x plus 2 equals to 0. Once again, the highest power of the variable is 2. So it is also the quadratic equation. The next one, here we have a x into x plus 1 plus 8 equals to x plus 2 into x minus 2. So by simplifying this one, this x and x gets cancels, and only here x square and x square it will be getting cancelled. X plus 8 equals to minus 4. That is x plus 8, 8 plus 4. That is x plus 12 equals to 0. Then here we have a highest power of the variable is 1. So it is a linear. It is not a quadratic equation. So the correct answer for this one is 2. Second, a person has 2 parents, 4 grandparents, 8 great grandparents, and so on. The number of his ancestors during the 10 generation preceding his own is 10 generation preceding his own. So one of his generation it is excluded here, and the previous 10 generation it is considered. So here we have a first, the person has 2 parents. From here it will be starting 2 raised to 1, 2 raised to 2, 2 raised to 3, and so on up to 2 raised to 11 it will takes, because first one it is excluded. So here we have a sequence. To 10 means it will be of 2, 4, 8 and all up to 2 raised to 10 it is. 1024 it will comes. Now here we have a S equals to, that is sequence equals to 2 raised to 1 and 2 raised to 2 and up to 2 raised to 10 it is taken. 2 raised to 10 and one more here we have a 2 raised to 0 also it will comes. One more it will be added for this. So 2 raised to 11 minus 2. 2 raised to 11 is nothing but a 2048 and minus 2, that is 2046. 2046 it is the answer for this. Then the next question is, if the coefficients of 3 consecutive terms in the expansion of 1 plus a raised to n are given in the ratio 1 is to 7 is to 42, then the value of n is. Now given the ratio is 1 is to 7 is to 42. Then now here we have a binomial coefficient. The binomial coefficient series C of n comma k, C of n comma k plus 1, C of n comma k plus 2. So here we have a first term, second term, third term, and fourth, like that it will be continued. In this problem, only up to third extension we have to take here, first term, second term, as well as third. So here we have a ratio of the second as well as first, second term and first term. That it will be C of n comma k plus 1 divided by C of n comma k. That it is nothing but a n minus k divided by k plus 1. That is a 7. It is given here. Then this n minus k divided by k plus 1. How it will comes? Now here we have a That's basic formula for C of nk, combinatorial equation C of n comma k equals to n factorial divided by k factorial n minus k factorial. So here we have a next term. This is the first term value that it will comes n factorial divided by k factorial n minus k factorial. And the second term value C of n comma k plus 1 equals to n factorial divided by k plus 1 factorial n minus k minus 1 factorial. So here we have a n comma k, this formula it will comes, n comma k plus 1. So here we have a, wherever there is a k, we have to substitute with a k plus 1. Here we have a k plus 1 means n minus k minus 1. That it will takes. And where we have a k factorial, we have to substitute with a k plus 1. So this is the first term and this is the second term. Now we have to find out the ratio between these two. That is C of n comma k plus 1 divided by C of n comma k. So here we have a, this whole term divided by this term, and n factorial it will get cancelled here. And then next here we have a k factorial n minus k factorial divided by k plus 1 factorial n minus k minus 1 factorial. This is a simplified formula from this one. So next what we have to do, here we have a k factorial and n minus k factorial. We can write these terms. K plus 1 factorial equals to k plus 1 into k factorial it is. That k plus 1 factorial can be written as k plus 1 into k factorial. That is 5 factorial is nothing but 5 into 4 factorial in order to simplify. And if up to 3 factorial we are doing means 5 into 4 into 3 factorial. Like that, if I consider this one as a 5, one less I have to take next term. That is a 4. Now k plus 1, one less we have done means it is a k factorial. So k plus 1 factorial equals to k plus 1 into k factorial. We can write this term in this way. And then next here we have a n minus k factorial. This n minus k factorial can be written as n minus k, and the previous, now it is a 5 means 4 can be written as n minus k minus 1. We have to reduce 1 here. So n minus k factorial can be written as a n minus k into n minus k minus 1 factorial. Then next here we have a again this we have to substitute these values here in this, where we have a k plus 1 factorial. I have to substitute k plus 1 into k factorial, and n minus k factorial I have to substitute this value. So this is the equation. In this equation, k factorial will get cancelled here, and n minus k minus 1 factorial, it will be get cancelled with this one. This term, and factorial, k factorial, that it will get cancelled. What is the remaining term? N minus k divided by k plus 1. The same thing we are having here. Means by simplifying with the formulas of C of n k, we'll get the value of n minus k divided by k plus 1 here. That is nothing but a given ratio, that is the 7. And like that only, next we have to consider first and second term we are considered, and this will be getting here. Like that we have to consider the second and third term here. When we'll consider the second and third term, here first term, second term and third term, ratio of the third term to that of the second term. Now C of n comma k plus 2 divided by C of n comma k plus 1. That when we'll be simplifying like this, we'll go through all these steps, we'll get this simplified step, how we shown this one like that. And here we have a ratio, it will be 6. That is 7 6 is 42. So we have written equals to 6. Then here we can go for this solution, or else just by using the heuristic method. In this we have a n comma k plus 1. K plus 1, k it has been reduced with a 1. So only k it is taken. Now here we have a n comma k plus 2. N minus k minus 1. we have to reduce that k plus 2, it has been reduced to k minus 1 here. And like that only, here we have a k plus 1. It has been incremented with the plus 1. That is a k plus 2. K should be incremented here and k should be decremented here. When it is k plus 1, it will becomes k. When it is k plus 2, it will becomes k minus 2 here. K minus 1. And this is equals to 6. Now we have to solve n equals to 8k plus 7 here. That just I'll take this part here, 7 into k plus 1, that is 7k plus 7, and 7k, this k as well as 7k together, it will be 8k plus 7, that is n equals to, we'll keep the n term here only and rest of all will be sending to the right side, 8k plus 7. And next term, this one also we have to simplify, we'll get n equals to 7k plus 13. By solving these two, we'll get k equals to 6. And this 6 we have to substitute here. 8 into 6 plus 7. That will be 55. So the answer for this one, it is 55. Is the number of different 8-letter arrangement that can be made from the letters of the word daughter so that all vowels do not occur together is. So here given the word daughter, 8 distinct letters, vowels A, U, E in this, 3 vowels are there. Consonants D, G, H, T, R, 5 consonants. So here we have a total arrangements. If we consider all the letters are distinct and when all the letters are distinct, the arrangement will be 8 factorial. That is 8 letters are there. Here we have a different arrangements. 8 factorial equals to 40,320 different combinations of the words we can get here. And then next here we have a in step 2, arrangements where all vowels are together. Here, all vowels are not required to take together. If they are together, it will be considered as a one block. If it is coming together A, U, E, it is a one block here. So, one vowel block plus 5 consonants. Total, how many letters in the word? All the vowels will be considering as a one letter here. So, total letters are the 6 items. Here, rather 8 different letters, we have a 6 items here because all the 3 vowels will be considering as a one component here. So here we have a arrange all of them, that is the 6 factorial equals to 720. Arrange vowels inside the block. Suppose now we have a 3 vowels together. These 3 vowels only, they can change their position and they can give the different meaning. So here we have a 3 factorial. 3 vowels are there. Different arrangement of these 3 vowels among themselves is a sixth. That is 3 factorial equals to 6. Total 720 into 6. Now 6 factorial into 3 factorial. That is nothing but a 720 into 6 equals to 4,320. Then next step, required vowels not together. But here if we consider the vowels together, it will be considered as a one component and among those themselves, it will be having the different arrangement. Suppose these vowels are not together, then here we have a total 8 letters will consider as a distinct and that 8 factorial equals to this much. That is the 40,320. And if we consider that vowel as a one component, in that case we have a 720 into 6 equals to 44,320. That is 40,320 minus 4,320 equals to 36,000. This is the answer. That is 36,000 is the answer for this question. So here we are solved some more questions related to mathematics and logical relations. In the next video, we can go for some more questions. Till then, see you. Thank you for watching.